Hello friends, welcome back to CCSP certified channel. My name is Rag and I have 14 years of industry experience. I have recently cleared CCSP exam and decided to help you guys in most important topics of the CCSP exam. I will start a batch soon to cover this in detail. In this video series, I will cover most important topics and this is third lecture. Today I am going to cover cryptography, basic concepts, and it is a continuation in the old lecture, the previous lecture. So it is a lecture 2. So if you are new to the channel, my suggestion is to have a look at lecture 1, then look at this video. So I come to the some quick recap, then we'll start the topic of the day. So as we have seen yesterday, the three most important topic or concepts in cryptography are confidentiality, integrity, and non-repudiation. We have seen that whole cryptography lies against these three concepts only. And the solution for confidentiality is encryption, solution for integrity is hashing, and solution for non-repudiation is digital signature. And we have seen one exam question also, that I have seen in my paper, that how to achieve the confidentiality of the logs. Then we have seen that the encryption should be the option, so at least the other two options we can roll out, and then so at least the concept will help to identify the two wrong option. So that we have seen, and we will go into questions later, but I will cover the concept first. We also have seen that there are two ways encryption works. One is symmetric, other is asymmetric, and I have taken the images from internet, so all the images are only taken for the educational purpose. CCSP certified channel claims no copyrights of these. And as we have seen that in symmetric there is a single key that helps in the both encryption and description, where the asymmetric key, it is two key pair, public key and private key, and in confidentiality or encryption only this receiver's public key play a role and receiver private key play a role in decryption. So there is no role Bob's public key and private key plays. So what is the role of Bob's public key and private key? That we will see now it in the non-repudiation section. But for encryption, it should be very clear, because it is being asked many times differently, that sender's key does not play any role in the encryption. It is a receiver key who play a role. And because of this, if the receiver key is wrong, someone let's say someone modify or someone do a mischief and the Alice public key modify, then message, even though it will go to Alice will not able to decrypt it and someone else will able to decrypt it. And that's why we have a PKI, public key encryption, that we will cover in the advanced topics. So as basic concepts, asymmetric key, we will just remember that the receiver's public key and receiver private key will play the role. There are some algorithms we have seen, and then there was a symmetric key versus asymmetric key differences we have seen, and we have seen that asymmetric key is much better in all the respect. Still the industry use the symmetric key because of the speed, because it is much faster than the asymmetric key. And we have seen that in the TLS, transport layer security, there is a combination of symmetric key and asymmetric key. Similarly, if you will cover this TLS part in advance, but there are many more example where the combination of symmetric asymmetric key play the role. So we'll cover those in advanced topic. But today's topics are integrity and non-repudiation, and we will cover them in detail now. And many of the CCSP exam questions, or even other ISC square exam question, or if you are in industry, you should be aware about this concept. They can be solved directly via these simple concepts. So as we have seen, encryption needs a key, and now we are part of integrity, that ensure the hashing is the solution, and integrity is the mathematical function that takes fixed or variable length input and give a fixed length output. So very important, the output is always fixed length and then we call output as a digest. So it is very important to know that the length of the input can be variable, but output is always fixed length. And if you see, if let's say A is input and output is 6 digit, 6 character, then it will be, even the input length is 1, output is 6 character. Input length is 2, output is 6 character. Same way 3, 6 character, and even 2 with different values, output will be 6 characters. So there are two most important property of the hashing. One is that no two inputs hash should map to the same output hash. Let's say if I give AB and XY, so there are two different inputs, output must be different, and it is almost impossible to have a two hash same for two different inputs values. I'm saying almost impossible because nothing is impossible. So 99.9999% time it is impossible to have a two hash similar. Now the second most important concept is we call is a one-way encryption. The reason is that we cannot regenerate plaintext from the hash value. So like we have seen in the cryptography, different cryptographic algorithms. So from hash value or the cipher value, we can able to decrypt and get the plaintext value. And the advantage of integrity or the hashing algorithms are that there is no way to decrypt it back. And there's the because there is no key. So hashing need no key. You have to understand and remember this concept. So let's say the encryption needs a key, receiver keys. Hashing needs no key, and the non-repudiation would use sender key. So there's three concepts, and should be very clear that hashing needs no key. It is a one-way encryption. There is no way to regenerate the plaintext from hash value, and there's almost impossible to have a two inputs hash and the same output hash. One more important concept is the output is fixed length. So there are a few examples of algorithms we have seen in industry. The SHA-1 that we call is a digest as an output. There's a 160 bit. SHA-2 support 4 outputs length, 224, 256, 384, 512. MD5 support 128 bits. So this is the integrity concept. I hope it is clear, and I will show in the next slide how it works. So again the same Alice and Bob example. So when message or the plain text being sent to Bob over insecure channel over internet, it is encrypted because here the encryption should be there. So it will make sure the confidentiality of the message. No one should able to see the message. But same time Alice do hashing, and then it generate an output. There's a digest. The whole message is encrypted. Now it can be encrypted or it can be sent. Digest can be sent in plain text or can be encrypted. I will cover that in next lecture. But at least message should be encrypted, and the hash is created and hash is sent along with the message, and the receiver is, and they will use the same hashing algorithms like SHA-1, SHA-2, MD5 and create a digest, and then compare the digest. If the digest is same, they keep it or they discard it. It will ensure the integrity, and it has a many advantage or many real time use case. Like when you install a page, you do a checksum, do a hashing or the same digest checking. So when you download a page, server has a digest value of that page. Post you download, you do a checksum analysis. It will just check the again create a digest and will compare the digest. So it will ensure that there is no change happen over the internet or the no packet has missed. The message that has sent from sender has received without being changed or modified at the receiver end. So that's clear, I hope. Integrity make sure the changes. So again I just re-emphasize, integrity does not matter whether you have read or not. It is the part of confidentiality. Integrity just make sure that it has not modified. So sometime the reading of the information is not important, the modification information is important. That's why the integrity is being used when you don't want the information to be get modified. There is a one collision attack that is in industry that has exploded over the time. The attackers has exploded. I will discuss them that quickly. Um, so that we have seen that the output is always same, and and it has a fixed length. And let's say when I give the A inputs, it will give the same hash. Again, I give the A input, it will give the same hash. So when the password are being stored in the database, it is stored in the hash value, and the attacker can give the different inputs and get the hash output and then compare the hash. So it is type of attack where the attacker can misuse, because they cannot decrypt it, but they can compare the hash. And same way the password hashing works. So whenever we store a password, it is stored as a hash value in the database, and when a user next time give the password is again hashed with the same hash function, and the hash value of the user input is compared with the database value. So this is how the hashing works. So no one can decrypt the password, can read the password. The same way attacker can use the collision attack, and they can use industry known passwords. They can perform the hashing of those passwords because there is no key. Hash function is publicly available. They can perform all the password hashing, and then compare with the database and can try to get the access of the user. So to overcome that problem, the concept of sol is being introduced. So as we have seen, the password length can be vary, the output is same, and the password, if attacker has a industry known password, they can produce the same length of same type of hash. So if we add a random keyword, a random character after that one, you might have seen in many banking websites, when you enter the password and they add some extra character before submitting. This is the adding the salt. Salt is the additional characters that's appended with the password. So let's say password plus salt become a password plus salt value here. It is being hash. Then output of the hash being stored in the database, and we note the salt value along with the salt. So attacker don't know this salt value. Attacker may only get the password from industry known passwords. So even though they compare, the value will not match, and they will not able to identify. Again, as I mentioned, these all images are taken from internet for educational purpose, so we don't claim any copyright for them. Now I come to some sample questions. Then I will go to the CCSP question also after this. So I just cover the first sample question. So let's say a lab administrator has configured a directory server to store password using SHA-1 hash function, and the minimum password length let's say is 8, and let's say salt decided as a 6-bit. So password length is 8, salt is 6-bit, and if the directory containing 50 accounts and their password, what is the length of SHA-1 digest? So these questions look difficult when we read, but if we are sound on this concept, it is very easy. So it has given the option 2 to the power 6, 2 to the power 8, 2 to the power 14, and 160. So one option is by from this value, one option from this value, one option by adding these two values. But the answer is 160. The reason is always SHA-1 digest output is same of, as we have seen, the SHA-1 gives the 160-bit output. So whatever the length of the password, whatever length of the salt, does not matter. Output is always 160 bits. So this types of tricky questions may come, and is also being taken from CCSP sample question bank. Now I come to the next question. The same question that came to me in my exam, but I have changed just the last language. So as we have seen that CEO decided to move some of his critical applications, on-premise applications, to cloud, but want to manage the logs to the on-premise system. So they want that CSP send the logs back to the SIM system or the on-premise systems. So this time, if the question asks to maintain the integrity of the logs, so previously, as we have seen, we have asked the confidentiality of the logs. If you see this question I have seen in my exam paper. when you want to suggest the maintain the confidentiality of the logs, then you go with the encryption. So it means that no one can see it. Let's say CEO is not concerned about someone can see or not. CEO is want to say that at least logs don't get modified. So if someone has performed an operation, someone has deleted an account, someone has created an administrative account, someone has changed the password, he wants that anyone can see. Let's see. That's not a big concern. The integrity is big concern. So someone should not modify this. Someone should not delete it. If the integrity is our main concern, then the always solution is hashing. So in that case, the answer will be hash. In this case, my answer will be my answer will not be the encryption. And the only reason is that it changed the way the business want. If the business want that my integrity should be preserved, I will go with the hashing. Now this is the CCSP question that I have seen in my exam. So if you want to ensure that the integrity of the baseline configuration VM images, if you read the question, if you see that how to ensure the integrity of the baseline configuration VM images. Now, if you are already preparing for CCSP exam, you might be aware that the baseline configuration is quite important for the security perspective. So all the auto scaling or all the infrastructure as a code features need a baseline configuration to be used, and in that case, baseline configuration must not be modified or changed by unauthorized person. So to make sure the integrity of this baseline, then what can ensure is the encryption can ensure the integrity? No. Is a digital signature cannot do this? It cannot. TLS cannot. It is the only hash. Hashing can ensure the integrity. So whenever the VM checksum or hash being calculated, it will give the same value if it is if it has a hash. The baseline has contained the hash value of the VM. So it will be hash based. Now I will show one more question that has come to CCSP exam of mine. How should CCSP share source code with customer? So one more thing. This is not I have shown you one line question to you because I want to explain the concept. But in exam it will not be single line. It will be 3-4 line, and some will be destructor. Will be not important lines. Only important will be the last or the question part. So they will say that CEO has sent an application to cloud and the logs are maintained there, and they have an agreement with the customer that they will share the source code for review, or they will use key escrow, or they will use the third party to review of the code. Similar like this, they will make some story. Then they will say that how you will say, or how the CCSP or how the administrator will share the source code to the customer. Now the sharing of the source code. So what is most important when they share the source code? Is the source authenticity is most important? Is the integrity is most important? Or is the confidentiality is most important? That I will not explain, I will not give answer as of now. You have to think that in this scenario, because whenever in exam they give the options, all 4 options looks good, but we have to think question in the way. For this perspective, what should be most important? Is the encryption is most important? Is this digital signature is most important? Or the hashing is most important? The hint is, or the solution of my solution is encryption, because the code is most important, that someone not able to see it. So that's why I will go with the encryption, but you will also do investigate at your end. Now I'll come to the last topic for today. This non-repudiation. As I mentioned that that it gives the authenticity of the source. That someone who has initiated the conversation cannot deny that he did not initiated the conversation. So as we have seen the hash algorithm previously, if we can encrypt the hash with the sender's private key. Now the sender private key taking a role here. It is a solution for the digital signature. So when a receiver receive it, it can decrypt the hash with the public key of sender, and as only sender has access of the private key, it will ensure the authenticity, source authenticity or message authenticity. So there are some example algorithm: RSA signature, digital signature algorithm, elliptical curve digital signature algorithm. So there are some example, and some of the important use cases DNS SSE. This for the DNS secure DNS protocol. I will cover this in advanced lecture when I will cover the cryptography advanced topics. So how digital signatures or the zone can be secure via the digital signature mechanisms. So DNS zone security is part of digital signature. There is one more concept, digital certificate. So if you see digital signature and digital certificate, so people may confuse with these two terms. So digital certificate is associated with the public key security. So as I have mentioned previously, that the public key play a very important role in the encryption. So when I'm sending a message confidentially, I need to encrypt with the receiver public key. So if someone, I have seen there is a man in middle attack, someone modify the public key or someone use on public key. I will explain that in detail when I will explain the digital certificate. Then a third party should be there to verify the public key. That's why the public key infrastructure will play a role. PKI will come. So in advanced cryptography, I will cover TLS, DNSSEC and PKI in coming lecture. I just covered the non-repudiation part. So as we have seen, the data is being hashed and the hash value is being fixed length or digest is the output. The digest is encrypted using the signer's private key, sender's private key. Because sender has the access of the private key, it becomes a signed hash, and the signed hash is being sent to the receiver end. When receiver receives this digitally signed data, and it has a data and a signature. So data is being used by hash function. Hash output is being taken out from the data, and the signature is being used by public key, sender public key. Hash is being output from that, and the hash being compared. Just one more thing, this path, the data part is here. The encryption is taking place, and encryption, as I mentioned there, it is a receiver private key will play role here. So when this hash is being calculated, signed hash, it is being attached with the message, and the whole message is encrypted with the receiver public key. So I just go back to concept one more. So it is message, it is hash is with the sender's private key, and it comes output digest, and whole box is being sent with the receiver's public key. So the first receiver will receive it, decrypt it with its own private key, because the receiver has own private key. It will get a message and the digest. Then digest, because digest is signed with the sender public key, receiver use the apologies. So when the digest is signed with the sender's private key, receiver take the digest and do the decryption with the sender's public key and verify the digital signature. So I hope I am able to explain the concept well, and this is quite important concept, tested many times in exam, and I just give one example of the exam paper I have seen. And even though we don't know concept well, at least we know what is the purpose of non-repudiation. It may solve a couple of our questions. So let's say why SIEM system is important. And the SIEM is as I mentioned, the event and log management system. Why it is important? Because it helps in non-repudiation, it helps in performance improvement, in the log analysis, in the disaster recovery. So as I mentioned there will be multiple correct answer, but we have to select the best answer after this. So SIEM system definitely help in performance improvement. So it identify which is the components not working well, or any incidents has happened. It identify that. It helps in the log analysis, or it help in some indirectly in the disaster recovery also. But the most important the concept is SIEM helps in the non-repudiation. So it maintains the chain of study of the chain of flow of the logs, and can help who has performed what operation That's very important. And so if you have a logs, and if you know with the exact timestamp who has performed what operation, he cannot deny that he did not perform that. And that's why the non-repudiation is most important feature of the same system. I think that's for the today. And the all three concepts, integrity, confidentiality, and the non-repudiation, I have covered. Next lecture I will cover the advanced topics. Those are TLS, DNS SSC, and the PKI digital infrastructure. Thank you so much. Be tuned, subscribe, and like my channel. Thank you.